Hello friends. Warwick is one of those champions that isn't too difficult to play and pretty easy for even the most brain-dead players to pick up. Considering the fact that he goes from 0 to 60 in a single frame, it doesn't seem very possible for Warwick to be pulling off these moves. But since League is a video game that doesn't care too much for the practicality of its movements, I thought we should take a look and determine how much should you really fear Warwick. Firstly, in order to estimate measurements in League, we'll need to establish a unit of measure other than feet, meters, or anything similar. So, we'll use Warwick himself. Since we can't determine Warwick's height post-rework 100% accurately, we must use another champion with a known height for comparison. Eventually, I found that Aatrox's height is about 7 feet tall, and when converted to metric is about 2.13 meters. Placing him next to Warwick, we can see that Warwick is about 80% the height of Aatrox, which means he comes out to a height of 1.71 meters. At this point, we should also determine Warwick's mass, which is about 140 kilograms. 50 kilograms more than the average male with a height of 171 centimeters or 1.71 meters. The extra 50 is used because old Warwick had a mass of about 111 kilograms, and I'm pretty sure that that tail weighs 30 kilos itself. Secondly, we need to calculate the velocity needed in order for Warwick to jump as high and as far as he does, and in order to do so, we need to find the height and distance of Warwick's parabolic leap. This gives us a length of about 3.4 Warwicks, which comes out to be about 5.81 meters. Now, the leap itself takes about 13 frames or 0.43 seconds at 30 frames per second, thereby giving Warwick a constant horizontal velocity of 13.418 meters per second. Next, we'll have to find Warwick's vertical velocity at the start of the leap. This is a bit more complicated than the horizontal velocity due to gravity and its impact. To figure out the initial vertical velocity, we'll have to figure out Warwick's maximum height. From this, we'll be able to calculate the vertical velocity needed to reach the height while opposing Runeterra's gravity. Warwick leaves about 75% of his own height in the air, which turns out to be about 1.28 meters, which is actually pretty realistic. Vertical jump records vary anywhere from 1.27 to 1.52 meters, putting Warwick as a record holder, but not a record breaker. So now, to calculate his initial vertical velocity, we'll have to reverse engineer this, figuring out how fast Warwick would be falling if he started at 1.28 meters off the ground. Because when Warwick reaches his peak, he's also at a standstill vertically, then the speed he would have falling from this height is equal to the speed needed to get to this height. Using the formula v squared equals 2ad, we can figure out that the square of our vertical velocity is 25.1136. So now all we have to do is root it, and we get a vertical velocity of about 5.01 meters per second. Lastly, all we have to do now is plug both the horizontal and vertical velocities into Pythagorean this guy's theorem, a squared plus b squared equals c squared. In doing so, we can see that the square of our final velocity is 205.143, meaning that our final velocity is 14.32 meters per second. Again, this is pretty realistic. 14.32 meters per second equates to 32.03 miles per hour, which is far less than that of a cheetah, the fastest land animal on Earth, and even slower than some canine species can run. So far, Riot's doing a pretty good job with the physics behind Warwick. However, if we look at the acceleration and the forces behind the leap, the image starts to get a bit unrealistic. Warwick appears to go from 0 to 14 in a single frame, or 1/30th of a second, or about 33 milliseconds, which is far less than the vast majority of pings, including mine, across the country while playing League. We can start to realize this even more when using the formula A equals V over T, where we can realize that despite reaching a maximum speed of only 14.32 meters per second, Warwick accelerates at 429.6 meters per second squared. Faster than... oh wait. Still pretty fast. Now, by using the formula F equals ma, we can calculate the forces that Warwick and the ground undergo every single time he leaps. As we found out previously, the mass of Warwick was about 140 kilograms, and when combined with the acceleration of 429.6 meters per second, we get a force of about 60,144 newtons. That's very large. For comparison, the maximum force achieved by weightlifters during a clean and jerk lift is about 8,000 newtons, only 13.3% of what Warwick outputs through his thighs. 60,144 newtons can also be viewed as 6,131 kilograms, or 13,517 pounds, 6.8 tons, heavier than even the heaviest of elephants. This force does seem a bit out of proportion with the rest of what is considered reality, but when compared with the force exerted from Warwick's ult when he's already moving with some speed, it's very little. Once again, to calculate the force exerted, we need to calculate the combined velocities of the horizontal and the vertical. With Tier 2 boots, Damman's plate, home guards, and blood sent via Warwick's W, he leaps about this far, missing the Yasuo entirely. Real quick, let's remove Nick out of the picture, and we can see that this distance takes about 1, 2, 3, 4, 5, 6, 7, 8.4 Warwicks to cover it. This gives us a large leap length of about 14.364 meters, which Warwick covers in about 16 frames or 0.53 seconds, giving Warwick a horizontal velocity of about 26.93 meters per second. Now for the vertical velocity. Just like before, the height is the only dynamic variable needed to calculate the initial vertical velocity of Warwick's leap, which appears to be about 1.6 Warwicks or 2.736 meters, meaning that it would take an initial vertical velocity of 7.33 meters per second in order to reach that high in the sky. But this guy's theorem again reveals that Warwick must have a total initial velocity of 27.91 meters per second. If we again look at the speed being achieved in 33 milliseconds like before, then Warwick's acceleration would be 837.3 meters per second squared. The formula F equals ma then reveals that the force exerted by Warwick on the ground and vice versa is about 117,222 newtons, roughly equal to the force exerted onto a seatbelt and thereby the passenger in a car that collides head-on with a concrete barrier at 100 kilometers an hour or 62 miles an hour. Keep in mind too that at the end of Warwick's leap he grabs onto the ground with the same force as when he launched, more likely than not ripping his arms apart. Or, the more terrifying outcome, he actually hits his ultimate onto another person with the same force that was exerted on the ground only half a second ago, launching the two forwards to nearly the same speed of 28 meters per second in almost an instant, killing both off. It even gets more terrifying because Warwick will be able to leap quite often. Bypassing the fact that he doesn't have the muscle for it, Warwick will be able to realistically get enough calories to leap quite often. If we use the formula k equals 1/2 mv squared, where k is the kinetic energy, that means that Warwick needs about 54.5 kilojoules of energy, which translates to a whopping 13 kilocalories. For comparison, a Big Mac contains 2,300 kilojoules, or 550 kilocalories, which means that just eating one Big Mac, Warwick will have the ability to jump 42 times before running out of energy. So when Warwick says,
"I fear me," say sure.
he's not wrong. Thanks for watching.